With that, we finally arrive at the actual calorimetry experiment. So I have explained to you the concept behind calorimetry, which is the principle of method of mixtures. Energy lost is equal to energy gained. And I have also explained to you what a calorimeter looks like. It's a device that helps you to control heat loss through conduction, convection, and radiation. So the typical task that is given to you is to find out what is the specific heat capacity of a metal that has been handed to you. Okay, and the method of doing the experiment is something like this. For the time being, just forget about the equations that are there on the whiteboard and concentrate on diagram to diagram how I am pointing things out. Okay, so the first thing is there is an unknown metal. Usually it's a small piece of a metal that is given to you. You can probably look at it and guess what it is in general, but you have to get some quantitative analysis done out of it. So that metal will be in the form of a bob or like a sphere, or it can also be given as a small cube. You have to find out the specific heat capacity of that metal in order to identify what that metal could be. The first part of it is that the metal has to be heated to a known temperature. Typically that is done by dunking the metal in water and heating the water. You measure the temperature of the water to know the temperature of the metal. This part of the task is usually done by the instructor. Okay, so when the metal bob, while the metal bob is heating up to a good temperature, it should be somewhere in the region of 80 to 90 degrees Celsius, you have to prepare your calorimeter. So what you do is you take a known quantity of water inside the copper container that you have been given. Typically we take 50 milliliters or 100 milliliters. It makes it much easier to do the calculations, and that amount of water is sufficient for the experiment. Then you have to find out the initial temperature of the water, which will probably be around room temperature. Okay, so you have the temperature of the water and you have the mass of the water. Now when you are ready, you tell the instructor to bring the metal and take it out from the container, immediately put it inside the copper container, and then shut the top lid and immediately start measuring the temperature. Now what is going to happen is that when the metal bob, so this is the part where you actually put the bob inside the water and then close the lid. So coming to the important part, which is where the heat transfer is taking place. The bob, which is hot, higher temperature than the water, is going to start losing energy to the water. Now the water will absorb the heat. Remember, water has a very high specific heat capacity, so it has a lot of capacity to absorb heat. It's going to also warm up as a result of the absorbed energy. Now the thermometer that you put inside the calorimeter box is going to measure a rise in temperature. Okay, and you have to observe the thermometer carefully to know what is the maximum temperature that it goes to. The increase in the temperature or the rate of increase of the temperature is not important, but measuring the highest rise, that is the point where the water and the bob are at equilibrium. So when the energy conversion stops, the energy transfer stops, the level of the thermometer has to be noted down. Okay, so let us say that water which was initially at about 25 degrees Celsius went to 35 degrees Celsius, and then it started coming down. So the temperature of equilibrium was 35 degrees Celsius. Now the next part of it is to note down all this information and then come to the theory part of it. So the theory part of it is that the energy lost by the bob will be the energy that has been gained by the water. So if you put that into equation, Qm equals Qw. So this is Qm, that is the energy given by the metal bob, and Qw is the energy gained by water. And if you break that down, you get the mass of the metal times the specific heat capacity of the metal times the change in temperature. So the change in temperature will be something, let's say, from about 90 degrees Celsius down to 35 degrees Celsius for the metal. Now for the water side of it, the right hand side of the equation, you will write down the mass of the water which you have measured before you put inside. Water has this unique property that 1 milliliter of water or 1 cubic centimeter of water has a mass of approximately 1 gram. So if you take 50 milliliters of water, then you have 50 grams of water. If you take 100 milliliters of water, you have a mass of 100 grams. Multiplied by the specific heat capacity of the water, which we know it is 4.2 joules per gram degree Celsius, and the change in temperature of the water, which went from 25 to 35 degrees Celsius. Now rearranging the equation for the unknown is the specific heat capacity of the mass, of the metal, that is equal to mw cw delta tw, mass of the metal mm times delta tn. And if you solve this, then you will get the specific heat capacity of the unknown metal, and by comparing it with the chart, you will be able to identify what that metal probably is. Now coming back to the part where I was talking about how does the calorimeter prevent heat loss from taking place. The conduction part I have already explained to you. The the wooden box, poor conductor of heat. The cloth that is wound around it, that also is a poor conductor of heat. So conduction is minimized. Coming to the radiation part, that is where the copper metal comes in. The copper metal will be highly polished. It can be highly polished, and therefore the radiation heat losses that are taking place can be minimized by this. It works in the same principle as that of a vacuum flask. The last part of it is which is the convection currents. So that works slightly counterintuitively. In the conduction part of it, if you look at this diagram, the heat loss is going to be taking place from the bob to the water. So the water in the immediate vicinity of the metal is going to heat up. Now if your thermometer is placed somewhere near the metal, then obviously the thermometer is going to be picking up the temperature of the water or even that of the bob. So that's where the stirrer comes in. Before you take the reading, every time you have to stir the water. What does that do? It helps distribute the water evenly throughout the body. Therefore, when you take a reading, you are taking the reading of the entire liquid and not just the part near the bulb of the thermometer. So in this way, all three different kinds of energy transfer, heat energy transfer, conduction, convection, and radiation are taken care of. And that's how the calorimetry experiment proceeds. I hope with that you understand clearly what is the idea of calorimetry and how the calorimetry experiment is conducted. If you like the video, please click like. You can share this video with anybody who you feel might benefit from it, and please do consider subscribing to the channel. Thank you.